Hello, everybody. I'm Steve Johnson. This is Digital Works TV. This is our Datazone. We're not necessarily talking about engineering, but we are talking about something that I think a lot of engineers would certainly be concerned about, and that's the future of NASA/Marshall Space Flight Center. Dr. Dale Thomas, a longtime Marshall worker. How long were you there?
32 years.
32 years. He now is a professor at UAH, University of Alabama in Huntsville. He is working on nuclear propulsion for space, which is all about going to other planets or other bodies in the universe. All right. One of the things that has been on a lot of minds, and I've talked to Marshall people, and you say, well, what's going to happen? And they go, we don't know. And you and I have chatted briefly about this, but do you have any feeling about the future? Would you rather, let me just stop here. Would you rather talk about NASA first or Marshall first?
Yes.
Okay.
Actually, it doesn't really matter.
Okay, well, let's start with Marshall since
Okay.
that's the one we're most intimately acquainted with. So what about the future of Marshall Space Flight Center? There's been a lot of angst about jobs, about people that have been on the job there for a long time, about money for SLS. Where are we and what does it look like, or where does it look like we're going?
Yeah, so I believe at the macro level, Marshall is in very good shape. They've got strong leadership. They're well positioned for key missions in the agency that have very strong congressional support. So at the macro level, you know, you look and you go, man, everything's solid. It's when you get to the micro level, you know, individual engineers wondering about their jobs. Are they going to continue? Are their jobs going away? That's where the anxiety and uncertainty creeps in.
Okay, well, you know, if I had a congressman right here, he'd say, well, the budget looks good. You know, what do you? Why would anybody be worried? But it's not that. So yes, there's plenty of money, not plenty of money to do all the things we want to do quickly, but there's money to fund projects. But is the money what it needs to be for what Marshall's doing?
Well, first off, I've never worked a single project during my days at NASA that could not have used effectively more funding. You know, as expensive as those programs seem, there are always things that you're not able to do that you would like to do. Okay. So, I mean, you can always use more money. That said, for the programs on the portfolio, they are reasonably funded. And as I alluded to, at the macro level, things are looking pretty good. During my early days at NASA, so let's rewind the clock back to the 80s, and some of the senior leaders that I was getting to work with, and I'm talking like branch chiefs, lab directors, and such. I'm not talking agency administrators. But these were some Apollo veterans, and they were very strict teachers. And one of the things you learn very quickly is a saying they had, and you've probably heard it from some of us before: the devil is in the details.
Yeah.
And if you want to successfully carry out a mission, it's not enough to work the big picture. You've got to work all the details. Every nut and bolt is tightened to the right torque. You know, all those details matter. And the details is where there's the anxiety and the opportunity in these budgets. Exactly where are the dollars going to go? Are they going to change the makeup of programs as they exist today and, you know, shut down contractor A and recompete, change it from a traditional acquisition such as a project office and a prime contractor to a public-private partnership? Yeah. That's where the disruption is coming, and that's what's driving, you know, the anxiety among the workforce.
Okay, I want to ask some questions about SLS, but first about the workforce. So people have taken retirement because that would I don't think forced, but they were suggested that it's time for some people to retire. So you got a guy who might have been there as long as you were, 32 years or and years and years, and yes, there are plenty of smart people getting out of college, even people who've been in the industry for a little while. But does it hurt a place like Marshall or any other NASA center to lose some of the folks that have been around the block and made the mistakes that they don't want to make again? Does it hurt to lose experience?
Oh, absolutely, Steve. Going back to what I just said in my previous comment, getting to work with the veterans of Apollo, and the shuttle had just started flying when I joined NASA in 1983. So the veterans of Apollo, the veterans of development, and the early operations of Space Shuttle, they had experience that you don't get in your classroom or out of textbooks.
Yeah.
And like I said, they were very harsh taskmasters. They would give you work to do, and there was not a curve, if you will, on the grade. You passed or you failed, and when you passed, it just meant you didn't get,
no reward, just not let go.
Right. That's what I was trying to say. Now, that experience was priceless to me, and though I didn't really enjoy getting a lot of that experience, I tried my best today in classrooms to share a lot of that experience. Yeah. If you look at successful teams, be they athletic teams or teams in organizations, think like the Jet Propulsion Laboratory team that landed, the rovers on Mars, and you look at the makeups of those teams, very high-performing teams and armed forces, whatever endeavor, invariably they are, and I know it's politically incorrect to say now, but they're a very diverse mix, okay? You have young whippersnappers, fresh outs with all the energy and none of the experience, and you have, the older people with plenty of experience and maybe not the energy they used to have. And you've got people with different backgrounds, and that's so valuable because the different backgrounds lead to different viewpoints, which help you catch mistakes that otherwise the team is going to miss. Okay, when we would have a bad failure, and we did have several during my time at NASA, we invariably would call them failures of imagination. We were not smart enough to see that this could go wrong in this way, and a different viewpoint might have caught it.
Hey, let's take a quick time out for some great news. Open enrollment is here. DigitalWorks Academy is offering a series of courses on model-based systems engineering. First up, an introduction to MBSE. This short course is designed for executives, managers, and senior leaders who want to know more about model-based systems engineering. The course explains what MBSE is, why it matters, and how it can improve the scope of projects from cost to schedule to quality. You will be more than ready to support your organization when it inevitably moves to MBSE. Again, enrollment is open right now. To make sure you have a seat, scan the QR code on your screen or go to the link at our website, digitalworks.org. To make sure there's a spot for you, register now. Enrollment is open. Okay, and here maybe is a great place to just remember, as our friend Mike Rodolphe Rudy said, spaceflight is hard. And
it really is.
It's a technical exercise, but essentially it's a bomb with the end cut off of it.
There's one way for everything to work right, and an infinite number of ways for things to go wrong is the bottom line.
Okay, so that takes us to SLS, which had a really glorious first launch.
Incredible.
It seems like a whole long time ago now.
Well, it was a long time ago. It was going on 3 years. I think it's like 2.5 at this point.
One of the things that happened earlier this year was the SLS was referred to as grossly overpriced, and then the money appeared to be going away for more than like one or two more flights, and now that money has pretty much been put back.
Right.
For multiple flights. I forget how many.
Four, as I recall. Okay. You could be right. It could be 5. I don't remember.
Well,
the exact number.
it's more than just 2 or 3. It's more than that.
Yes.
So is that a reason for everybody at Marshall to start jumping up and down?
So I think it's a reason actually, and knowing the Marshall culture as I do, folks are going to double down, because now it's like, okay, we've been given a few more flights. How can we make this rocket operate more efficiently?
Yeah.
How can we make it cost less? How can we make it perform even better?
Yeah.
Okay. Because as you alluded, the first flight was an amazing success. But when you get into the details, and by the way, I've not seen all the
Yeah.
post-flight analyses. But the one thing I can tell you is there's some things that made some of the engineers raise their eyebrows. Okay,
Yeah, well,
and they want to tweak some things because what SLS absolutely cannot afford is blowing rockets up the way SpaceX
No,
does.
and blow rockets up, and/or the next flight will have human beings on it.
Exactly.
And let's just say one thing. You say one thing about make people understand, the ones who might not be familiar with how spaceflight works. Human rated is a whole lot different than a rocket carrying a satellite into space.
Well, absolutely. If a rocket, malfunctions, they typically tend to malfunction spectacularly.
Yeah.
I'll put it that way. As a matter of fact, we're a little superstitious at NASA, and we don't use the word explosion. We use the term rapid scheduled disassembly.
Yeah.
Unscheduled disassembly. All right. But when we talk about human rated, that's when we have gone even further in trying to assure that if there is a problem with the rocket, that the crew will survive.
Yeah.
And so you go into all kinds of abort scenarios, you add extra capabilities to the rockets to basically sense when an accident is or when a malfunction is coming, so that you can start taking steps to get the crew safely off the rocket during ascent. And that's complicated.
And certainly adds to the price.
Oh, yeah. Well, you're adding all that extra capability.
Yeah. In fact, if you read about some of the disasters NASA's had in the past, and Apollo 1 is a perfect example, and maybe even Challenger 2, there were changes
Absolutely.
that had been recommended, could have been done, but the budget kind of precluded doing a few things, or we're just going to hang with what we have for the time being, and then after the disasters, these things were changed because you knew that you had a weak point.
It's interesting you make that analogy. Those are actually two very good examples because, both Challenger accidents and going back to Apollo, the scenarios, those were not really failures of imagination. The scenarios had been imagined, but we fell into a culture I believe it was Diane Vaughan coined the term normalization of deviance. So you get a few success.
I feel like remind me of that. I want to write that down.
Okay, well that's where.
No, I totally get what it means.
Okay.
But I just want to write it down. That's a good phrase.
Oh yeah, it's fantastic. Well, it is what happens where you're doing something that is not safe or not wise, and you keep getting away with it.
Yeah.
And so before long, that just becomes the normal behavior. Okay, you accept it. And what it did in the case of NASA for both of the shuttle missions was it took the sense of urgency off of making those corrections. And making the corrections, redoing the booster joint in the case of Challenger, redoing the foam on the tank so it wouldn't shed in the case of Columbia. Both of those were known problems in work, but, the shuttle was flying successfully. Those upgrades were business as usual. In the case of Apollo 1, that was more a case of where, you had two warring technical communities, working. It was still a little bit of normalization of deviance because Gemini and Mercury had flown with that pure oxygen, I believe, 5 psi atmosphere.
And did they also have a door like Apollo 1 that opened inward?
So the answer is I'm not sure. I would have to check
that.
that.
And that was, there was...
Yeah, once it overpressured, there was no way to open the hatch.
Okay, so, one of the things about SLS, it appeared, looking at it from the side, they've been very careful. The folks at NASA are very careful because the understanding now is, one of the Apollo guys told me years and years and years ago, we blew stuff up all the time. And
sort of like you see SpaceX doing today.
And some of their early launches, they learned stuff, What was the one where they had multiple problems and still made it to space and still carried the mission. Is that
I believe that was 12.
and
I
and,
think.
and still because the redundancy built in, but that redundancy was built in for that very reason. But they learned stuff. But in the current culture in America, it does appear that if you have a test that doesn't work, it's because the vehicle's bad and we've wasted zillions of dollars, and that is an added pressure, isn't it, on the folks at Marshall or at NASA trying to fly human beings into space.
Absolutely. And what it leads to is areas that, are actually okay. Well, they get revisited and gold plated. And yeah, in the course of all that diligence, you do find potential flaws and fix them. But, at the same time, you're fixing a lot of non-problems as well. And so, yeah, that's why it gets so expensive.
Okay, so one of the things that will happen on SLS, on Artemis 2 and Artemis 3, they're going to be, if you want to go down there and watch the launch, you better be rich because you're going to have to rent a house for a month. because they will be so careful that I think that's too hot to the touch. Okay, we're not flying. I mean, you know what I mean? I mean, it's going to be so careful to avoid anything horrible because they don't want to hurt anybody get hurt. But it sometimes seems like, well, they just built a bad rocket if it takes so long to get it in space. But they're just being careful.
They're just being careful. And you go back and look at SLS, the maiden launch, I'll call it. They would get out to the pad and, they would tank it and go, oops, something doesn't look right. And so they would.
Didn't they have the hydrogen?
Yeah.
The hydrogen wouldn't kept leaking from the fitting to fuel the rocket.
And things like that, could they have flown? Probably. Okay. But, it was an uncrewed mission around the moon.
Yeah.
The moon is not going anywhere. So it's like, well, why take the chance? Let's try again, in a couple of days after we've had a chance to study this. So very deliberate, trying to avoid, anything. Now, having said that, if there had been a national urgency, the SLS could have launched much sooner than it did.
Yeah.
But they were just going the extra mile.
These next two with people on them.
Well, they will go the extra mile on those too. It's funny you alluded to you better rent a house for a month because on the original launch date, I think they were setting up buses for students to take them down to Kennedy, and I said, I'm not going to go because it's not going to launch. And they would look at me funny, and I said, it's going to be a complicated endeavor. And then you had some folks who went down the second attempt and so forth. But don't get me wrong, I would love to have been there for it. I would love to have been, in the firing room. But I knew trying to go down, no new vehicle is going to launch on its scheduled launch. Well, no, it just doesn't happen.
It's hard. Okay.
Too much to go wrong.
Okay, so we know they're going to be careful.
And by the way, one of the points I was going to make is, the SLS that launches on the next mission, like you said, it's going to have crew on it. It's going to have, I'll just say, some parts that were not on the, first mission. So yeah, they're introducing more things that they'll want to make sure are really dialed in, and they made a few tweaks, as I was alluding to, to try to fix things from the first flight. So yeah, all those are opportunities that they will have to make sure are,
and one thing I think that needs to be mentioned, the thing that has delayed Artemis 2 is much more about the Orion capsule than it has been about the actual rocket. Am I correct on that? Yeah,
we used to have a term, we would call it, all right, who's going to stick their head up out of the foxhole and draw the fire?
Yeah.
And, a case in point I'll give you is Chandra, when it was queued up to launch back, I want to say, in like 92 maybe. But anyway, in the wake of Challenger, it couldn't launch. So they were able to fix some problems that otherwise they would not have had they might have run into some schedule difficulties, not bad ones. Okay, they were pretty well, they were almost there. But as it turned out, they, were granted a little extra on the way because their launch vehicle wasn't ready. So it's like, okay, well, let's go do this test and that test and, make sure everything's ready.
Well,
And so Chandra, boy, it was, ready to go when their slot came up.
Well, am I correct? And I don't want to belabor this, but the space shuttle itself, which, it's well documented things that have happened, but as robust a space vehicle as ever been reused is what we're talking about, was the most complex machine in human history.
I would not argue that point.
With millions and billions of parts and thousands of systems. So I mean, the fact that it was flown and reflown, and am I correct? Some of the rocket engines that are used on SLS flew.
You are absolutely
flew
correct.
On space shuttles.
Yes.
So that the engine is an incredibly efficient and incredibly expensive engine, but in testing, it's done pretty well. The fact that it's going to get to fly years and years after the end of the shuttle program speaks well that somebody built something right. Okay, so Marshall SLS, that's not the only thing going on out there. And talking and doing an interview here with Joe Pelfrey, he says that unlike the Apollo years, Marshall is a very diverse place with lots of things going on. So when you hear that and think about that, do you feel like, okay, Marshall Space Flight Center, SLS aside, budget questions aside, is in pretty good shape. There's a lot going on. It's not just a development center anymore, which it was during the Apollo years, and we landed on the moon, and everybody was celebrating, and people were had been being laid off at Marshall Space Flight Center for 2 years. So is Marshall pretty secure just from all the things going on in your mind?
I believe they are. Okay, and the reason is because some of those other missions that you were alluding to, other than SLS, are have very strong support out of the Congress. You alluded to the space nuclear propulsion earlier. It was zeroed by the administration in their budget submit to Congress for FY26. Both houses wrote that program back in to their bills, okay? And I just offer that as one example. Mars sample return also is called out in those, and Marshall has a lead role in that project as well. So one of the areas that would have potentially hit Marshall was the big cut in science, because as you alluded to, Marshall is not just, quote, a development center, unquote, any longer. It also has science, space technology work, and both houses, of Congress in the appropriation subcommittees, okay, basically, restored or carried over last year's funding and specifically called out, the continuation of projects and programs. So that would have been one risk. Those big cuts would have had to have hit Marshall. You couldn't take all of it out of Goddard and JPL. Yeah. So, I think by and large, at the macro level, Marshall is in very good shape.
That macro thing, so we have to look it up on Google. If you had a chance to just address the entire Marshall Space Flight Center workforce, what would you tell them? And not there's a million things you could tell them, but what would you say if you were going to tell them a couple of sentences? From your experience, you guys, you ladies need to. What would you say?
Well, you need to do the job that you're assigned to do extraordinarily well. The term we used to use back in my days at Marshall, keep your head down in color. There is no substitute for success.
So many good sayings in space science.
Yeah, there is no substitute for success.
Yeah.
Okay. You had mentioned Rudy earlier, and I'll never forget, we were having a conversation one day, and this was in a meeting, and we were talking about one of our programs being at risk of going quite a bit over budget and being quite a bit behind schedule. And Mike countered with, well, everybody forgets about the cost and the schedule if it works. And, he overstated that a little, but his point was very valid. It has to work. It's when things fail and they were late and too expensive.
And people say, look how much money we spent.
Was wasted.
Incompetent,
Yeah, yeah. So that's the real thing. The other thing I would offer them, and this just comes from, many years, and, the cancellation of programs and so forth, and, rumors of reductions in force and so forth, is things are never as good as you think they are, nor as bad as they appear.
Okay. Would you say that goes for NASA as a whole?
Oh, absolutely.
So Marshall is a microcosm of the overall NASA.
There you use the word micro.
But yeah, but agency wide, you think it's kind of the same situation?
Absolutely. Every center is unique in their project mix and what they do. But I don't know of any centers that are totally siloed in one area. And so, yeah, to a degree, that would be my message to the entire agency.
Okay, people watching this, and I read things like this. Well, how come SpaceX? Well, look at SpaceX. You mentioned they've blown up a lot of stuff, but they don't seem to there's no penalty paid for that.
Right.
Not like it would be at Marshall. But why? SpaceX, they're landing their rockets back on the pad after they're saving money. I mean, what is the difference between what SpaceX is able to do and what NASA is able to do in your estimation? First of all, let's just say American taxpayer money funds SpaceX just like it does NASA.
I'm glad you made that
Most
point.
of the people who work at SpaceX used to work at NASA. So, and they've got all the rocket information NASA ever did. They started out with that.
Yeah.
So they're kind of ahead of the game when they started. But what's the difference?
Well, the biggest difference goes back to culture. The NASA, because it is very engineer centric, is always looking at performance. So if I were to use automobiles, I'd say NASA is focused on Ferraris. Always trying to get right to the edge of the envelope. And the reason is because, it's really hard to get a rocket to space. So if you get a rocket to space, you want to try to make it perform as well as possible. Yeah. Okay. Well, Elon Musk, had come through Silicon Valley, had a hand in many businesses. And so Musk actually backed off, getting to the edge of the envelope. And he says, I'm not going to try to launch as many pounds to space as a rocket could conceivably carry. I'm going to try to build, a Volkswagen. And that's exactly what the Falcon 1 was, okay? Reliable, boring, okay? If you look at the performance specs on the Falcon 1 and compare it to like an Atlas, okay, you'd go, why did they even bother? I mean, it doesn't compete. Well, until you look at the price tag, to get, albeit fewer pounds, but to get it to space. And it was like, oh, well, okay. So Musk was focused on it from a business angle. And he said, we're going to not try to get the most performance out of the rocket engine that we can, but we want that engine to be cheap and reliable. Okay, and same for the various other aspects of the rocket. So in terms of performance, none of the SpaceX rockets, would really catch an engineer's eye, but the price really does.
And isn't that's really kind of the philosophy the Soviets, or excuse me, the Russians now have had. They're still flying. Am I correct? A lot of their technology is still based on 60s stuff.
Yeah, I don't know that that's because of that philosophy or just because they haven't had funding to upgrade and modernize their systems.
But at least you could say it was tried and true. I mean, for the most part.
But continuing on that whole thing, that's sort of what finally made the commercial space sector take off. And you look at the New Glenn with Blue Origin and the Vulcan with ULA. And that's just to name just two.
And ULA rockets, am I correct? ULA are really good Volkswagens.
Well, the Vulcan is. Now, you go back and you look at the Delta and the Atlas, the ones that they're riding out. Those, while they may not be Ferraris, they are definitely top-end Corvettes.
Okay, okay. Well, that's pretty cool. Yeah. Okay, so bottom line here, there's a difference between SpaceX and NASA. We already knew that, I guess. I mean, but people should not judge NASA the way they judge SpaceX, or even vice versa. It's two different ways of trying to do similar things.
Yeah, and it absolutely is. And, both ways have their flaws.
Yeah.
Okay, and both ways have their strengths. And ideally, what NASA is trying to do with these public-private partnerships is harvest the best of both.
Yeah.
The rigor of the NASA methodology, particularly when it comes to crew, along with the economies that come with the commercial approaches, where they're flying, I would say, less exotic,
Yeah.
configurations.
Okay, so I want to pick your brain here. This is and
Sure.
this is stuff that I will say up front. You don't know. This is what you think. Okay. Will we go to Mars? Will we put people on Mars within the next decade?
No.
Will we put people on Mars within the next 20 years?
Yes.
Will it be just a U.S. mission, or do you think there will be collaboration to make it work between countries?
There will be collaboration.
Okay. How long before we send human? And Mars is like, and there are many people have written many articles about, why do we think so much about Mars? We ought to go. How long before, if you were just going to put a time on it, before we send a mission to one of the moons of Jupiter or Saturn, till we send a mission to one of these intriguing places?
Yeah, so that is really cool, and that's the kind of stuff I think about. But I honestly, unfortunately, think it'll be into the 40s before we can try such a thing. Now, you're talking about sending people.
Oh, I'm talking about sending people. Yeah, we're the sending of gear.
It turns out, if you can get to Mars, you can get to Jupiter, and the question becomes one of time. In my lab at UAH, we've run trajectories, and with nuclear thermal propulsion, you can get to Jupiter in 2.5 years.
Okay.
For a rendezvous mission.
Okay. So okay.
To go into orbit, not just to fly by.
Okay.
So, and that, as you know, that's a game changer, because to get to Jupiter with the rockets we have now, you have to do these exotic flyby trajectories, and sort of like driving to St. Louis to drive to Atlanta.
Yeah. I've actually driven to St. Louis to go to Arkansas.
Well, okay, there you go.
So, okay.
But that's a 5-year.
Okay, so five years, and I always hearken back to the movie The Martian, which had a spacecraft that appeared to me to have everything you would need for humans to exist and be healthy, because there's nothing about space that isn't trying to kill you. And in fact, there was an article that I read just yesterday about, you say you want to go to space, or people want to go to space. Well, it sucks. And there's really nothing about it that's healthy or not trying to kill you. But that said,
space is not trying to kill you. It's ambivalent.
Okay, well, that's true.
It doesn't care.
That's true.
Whether you live or die.
So, how long? Do you believe in the next, we'll say 30 years, because that's just a number, we will have a long-term human habitation? I think we're going to have it on the moon not that long from now, but on a place like Mars. Do you think we'll be able to put habitation and keep people there in the next 30 years?
Yeah, so that's a good question, and I'm going to give you two answers to that. The first is, if we can sustain the political will, and I don't mean just political out of D.C., but I mean as a nation, because commercial is going to be a big part of that. So if we can sustain the will, technologically speaking, it's absolutely very doable. Okay, but our nation does not like to commit to things long term. Elections happen, and one of the things that the new party coming in wants to do is differentiate itself from the old party. I lived through some of those kind of transitions at NASA, and programs got axed. Well, and hence, simply because they were associated with a prior administration.
And there has been some movement and plenty of talk in the last several years about creating a council that runs space research and takes it out of the political realm. But until paying for things is out of the political realm, that's probably not realistic.
Right. all I'll say is, as an engineer and NASA veteran, I would love that. I simply don't see Congress nor the executive
Yeah.
ever surrendering that power.
Okay, one more question, and then I want to run something by you and see what you think about it.
Sure.
What is something you think is going to happen in space in the next 50 years that most people don't even think about now? What is something you think is wildly imaginative, but you think, yeah, we might do that? What's something like that?
Yeah, well, most people probably find it boring, but I think we're going to continue to develop some very exotic telescopes, see ever further back in time. And the next generation after Webb will let us get even closer back to the origins of the universe. And we're going to continue to discover things that make us question the basic model of physics.
And that is actually happening right now. I mean, there are numerous news stories out in the last year of stuff like it appears the Milky Way is, our galaxy is in the middle of a vacant lot. And that may say something about how we think the stars are moving away. Well, maybe we're the one, it's just really cool.
For example, we've conveniently come up with this thing called dark matter and dark energy to explain the stuff we can't see, and yet we see as happening. So, the wild thing I think will happen within the next 30 years is we will actually find out that we don't understand some of the elementary forces at the mega scales that we think we do. And so rather than, finally uncovering dark matter and dark energy and we have everything together, it's like, no, we're more confused than we've ever been.
Okay, something that I read this week, and I just want to see what it makes you think. What Voyager's been traveling for 48 years.
Yeah, it's now
48 years.
Out of
48
the solar
years.
system.
It's not even in our solar system
Right.
anymore. One light day. That's how far away it is. And we are many light years away from any habitable planet.
Oh, yeah. I think like...
But should that dissuade us from anything? Should that just be, oh, that's the way it is now, someday? I mean, because I often think people don't, well, why are we doing, we can't go anywhere. But
Au contraire, we've got a solar system here that we can explore, that we have not explored, okay? And I was just mentioning, we've done flybys of planets, and we've even done orbiters of like Saturn with Cassini, but we've discovered that Saturn has hundreds of moons, not tens. We thought we knew the moons of Saturn. No, we were way off, and we're probably missing some. And we may be missing some of the Jovian moons as well.
We believe now there's a planet past
Planet
Pluto.
X, yeah. So, and people are scratching their heads. Nobody's seen it, but the math suggests.
And it's dark. It's not reflecting anything.
Right. So, it's sort of like lamenting that you can't go to Europe for a vacation. And I would ask, well, have you been to Montesano State Park? And, in the case of, no, you might ought to check that out. So, yeah, we are generations off from visiting and exploring other galaxies, but we're not that far off from exploring our solar system.
All right. Well, then that is a very positive note, and I think that's where we're going to call it a day.
All right,
Dale, thank you a lot.
It's my pleasure, Steve.
That's fun. I hope they think it's fun. Anyway, thank you for being with us. Thank Dale Thomas, and thank you for being with us on Digital Works, our Datazone, talking about NASA and the future and space travel.